Okay, section 2.4 is on using postulates and diagrams. This is brand new to, I think, all of you because we haven't covered postulates yet, and it's very different from Algebra 1. So how to use postulates to analyze diagrams. We have some definitions. The first one is line perpendicular to a plane. A line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So some postulates, postulate 5. And you don't have to memorize these. If this comes up on like a homework question, feel free to look them up. You don't have to memorize what these numbers are and everything. Postulate 5 says that through any 2 points, there exists exactly one line. Okay, and that's something you should know. You should know that if there's 2 points, there's exactly one line, but you don't have to know that that's postulate number 5. Postulate 6 says a line contains at least 2 points. So basically, if there's a line, then there's at least 2 points in that line. Postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. Eight, through any 3 non-collinear points. There exists exactly one plane. And I think I spelled that wrong. There's 2 L's, but we'll go with it. Actually, I might zoom in. I think I gotta get rid of this 1. There. That's better. So there's 3 points that are non-collinear, so 3 points that don't lie in the same line, then there's exactly one plane. Postulate 9 says a plane contains at least 3 non-collinear points. 10, if 2 points lie in a plane, then the line containing them lies in that plane. And then lastly, postulate 11, if 2 planes intersect, then their intersection is a line. Okay, so we're just going to talk about those postulates and show a little more what they mean with pictures. So use a diagram to write examples of postulates 9 and 11. So postulate 9, if you look right above, postulate 9 says a plane contains at least 3 non-collinear points. So what we would say is, like, if you look at plane Q. So your plane Q is the shaded one. There are 1, 2, 3 points. Those 3 blue points, actually I'll make them yellow so they stand out more. Those 3 yellow points are non-collinear. So we would say plane Q has non-collinear points V, Y, and W. Okay. And for postulate 11, which says if 2 planes intersect, then their intersection is a line. So if you look at the picture, let's go with green. You see the shaded and the white plane? They cross on this green line. That's where they cross. So we would say plane Q and plane P, okay, Q and P intersect in line B. Gives us an example of postulate 11. All right, so checkpoint, use a diagram from example 1 to complete the following exercises. Which postulate allows you to say that the intersection of line A and line B is a point? So which one allows you to say that two lines intersect in one point. That would be postulate 7. Okay, and again, you don't have to memorize this, but you should know that when two lines cross, they cross on a point. Write an example of postulate 5 and 6. Postulate 5 says through any 2 points there exists exactly one line. So we would say is through points X and Y, there is only one line. And that will be line A. So if there's 2 points, there's only one line. In this case, it's line A. And postulate 6 says a line contains at least 2 points. So if we look at it, we could say, okay, well, line A has points X and Y. So that'd be an example of postulate 6. So slide down. Example 2, identify the postulate illustrated in the diagram. So I'm just going to write down an if-then statement. So what this statement is saying here, because this is really what we're trying to figure out. I don't care that you know what number postulate this is. This says that if, or so it says if there are 3 points, then there is a plane, right? They're saying if 3 points, then plane. So let me actually erase the I. What we could say is through 3 non-collinear points, there exists a plane. Or there exists exactly one plane. And that actually is postulate 8. If we scroll up, postulate 8 says, through any 3 non-collinear points, there exists exactly one plane. Okay, example 3, use given information to sketch a diagram. So sketch a diagram showing segment RS is perpendicular to line TV intersecting at point X. So I want to start with segment RS, it intersects line TV, and it's perpendicular. So it's got to be perpendicular, so it's got to form a right angle. Line TV, and it crosses at point X. So this point right here is point X. That's how that would look. The blue one has to have arrows because it's line TV. The red one does not have arrows because it's segment RS. You need to have the right angle box. You need that box to show it's perpendicular, and you got to put point X there. So that's what that sketch would look like. All right. Okay. Example 4 is interpret the diagram in 3 dimensions. Which of the following statements can be assumed from the diagram? So can we assume that point E, D, and C are collinear? So E, D, and C. Can we assume they're all on the same line? Yes. Because in the picture, they clearly are on that same line. They're on the line that goes vertical through that white plane. Now, can we assume that the intersection of line BD and line EC is point D? That one is also yes. Because you see line BD and the line EC cross at point D. So we can assume that because 2 lines cross at a point. Can we assume that segment line BD is perpendicular to line EC? So the green and red line, can we assume they're perpendicular? Is that something we can say from the picture? And that is no, because there is no right angle box. You don't see that little marking to show it's a right angle. In order to be perpendicular, it's got to have a right angle. We don't know if it's a right angle or not. So the answer is no. And can we assume that line EC is perpendicular to plane G? That is also no, because again, there's no right angle. So you need to have the markings in order to assume that, and there's no markings. So in the checkpoint, using the example 3, if the given information indicated that segment RX and segment XS are congruent, how will the diagram change? So in the diagram above, right up here, it would look like this. How would it change? And this is actually something that we had some mistakes on our quiz. So I'm going to draw the same exact diagram, except for if RX and XS are congruent, so we have X right in the middle, we have to mark it like that, and it's got to go through the middle of segment RS, right? We can't, you see how up above that, let me use yellow. You see this yellow part is different than the red part up above. So look up here on top, look up here. The yellow part is bigger than the red part, obviously. Down here, I'm going to make sure that the yellow part and the red part are the same, and I'm going to mark them. You see those marks? And then I'm going to draw my line. This is line T, V, and I'm going to draw my right angle box. So now it's same drawing except for we had to add those congruent markings. And then number 4, in the diagram for example 4, can you assume that line BD is the intersection of plane F and plane G? And this is actually yes. And the reason why is 2 planes intersect in a line. Fix this. All right, and that's all we got.